hottest topic in the market, technology-wise and job-wise also. So I thought to share my experience over this generative AI, what all the basics of the generative AI, the different algorithms that we are using in generative AI. There are many, the various tools that we can use to create generative AI algorithms. So we'll be talking about that. So first, let us start with the basics to understand how we are able to reach to this generative AI concept. That is the topic. So we just start with the first core idea. When this is a subfield of artificial intelligence. So when we say artificial intelligence, we refers to simple simulation of human intelligence, and there is a machine that are programmed to think, learn, and perform, as typically which requires human cognition. So a system can process and analyze data. It recognizes the patterns and it makes decision and improve over time without explicit programming. That is the main idea of AI. So when you look at the broader part of AI, now as you can see in the image on the left side, we talk about artificial narrow intelligence. Then we'll talk about general intelligence, and we also talk about artificial super intelligence. Talking about a narrow intelligence wherein we are at present, and this is also known as a weak AI. Why it is basically known as weak AI? Because for a specific task, we are designing our algorithm. We were designing our algorithm so far for a particular specific task only, and it is specialized in a narrow domain. So this type of AI can like a particular functions which is very well often surpassing the human capabilities in that task. But it lacks the ability to perform a task outside its predefined scope. Say, for example, we talk about Siri, Alexa, the recommendation systems that we have. We also talk about the self-driving car, the algorithm which is used for all this different domain. They're very specific. They have their boundary. So once the boundary is set, it won't think out of its way. So intelligence is there, but that is based on the handcrafted features. So what is next actually? So the next is, and we are moving towards the era or the technology wherein we are looking for an artificial general intelligence. And when we talk about artificial general intelligence, so it won't exist as such now, because it requires a system that can independently learn and adapt across variety of complex tasks. It's not about just one complex task, but it is all about multiple complex tasks, much like a human being think, learn, and solve the problems. So we also call it what is strong AI and kind of human level AI. And it is a machine that has the ability to understand, it learns and apply intelligence across broader range of tasks, and which is very similar to human. And when we talk about this general intelligence, it is able to reason. It solves complex problems. It makes decision under uncertainty, and even exhibit creativity and emotional understanding. Now we are trying our best now. We are growing in all sides to come out from the traditional way of writing algorithm, which we right now we all started with statistics. Then we moved to the machine learning algorithms. Then we are moving to deep learning algorithms, and thereafter there comes a new era wherein we are trying to make the system so intelligent like a human being. This is what is our effort, and this is what we are trying for. So AGI, which we call artificial general intelligence, so far we are trying our best with a theoretical concept, and it has not been achieved fully. That is what we are trying for. Then comes the next level, which is known as super intelligence. So when I say super intelligence, we are talking about something which is above the level of this general intelligence. So it exceeds all human intelligence, above human intelligence, because any task that is given which human cannot solve could be solved by the machine. So we have not reached to that particular point where the whole system, the whole world, or the whole complex system that works in the entire world will be controlled by a system itself. Like we, as a human being in group, we try to control different region, domain, demographic area. That way, with all complex problems, we try to solve it. In a similar way, uh, uh, to overcome that, I mean, something which is above that is actually is your artificial super intelligence. So, in short, I just want to say that coining these words, like when I say artificial narrow intelligence, it is specialized, narrow in the scope, like as I said, Siri, Google search, whatever search that you do, or recommendation system, this kind of thing, or self-driving car. And then when I talk about the general intelligence, it's a theoretical general purpose AI, like a human mind, that is equivalent to our intelligence. And when we say the super intelligence, it means advanced form of AI that far exceeds the human capabilities. Okay. So these are the various steps. So now at present, we are trying our best to come to this artificial intelligence, general intelligence. Now, as you can see, various other broad aspects. We talk about machine learning. We have knowledge base based on which the machine learning works. And there are various applications like computer visions, robotics, natural language processing. And we can do automations, planning, and scheduling. For example, like I book a ticket. Now I book a ticket, airplane ticket. So I can do web check-in, and that web checking can happen automatically. I don't need to actually suppose it is 3 hours before I have to do, or 10 hours before I have to do, or 24 hours before I have to do. It is being scheduled, so it will get done automatically. Even the boarding pass automatically we can schedule. So all these things can happen. At the same time, the artificial intelligence, all algorithms can also be optimized, because we have several different types of algorithms very much with us, which is nature inspired, or with all the different types of optimizers. So these are all possible. Let us move from the basics. So when we started with AI, the very first thing was the statistics. We all were working with statistics, and we had many tools like SPS. We have Vika, and we were making use of these tools to do a kind of analysis over the data that we have. And we are doing mathematical scientific application also through these softwares or platforms only. But all of these have got its limitation also, because it just deals with some set of data and gives some output, and it doesn't learn as such that we are looking for. As human being learns, it doesn't learn something out of those data. It does the calculations, but it doesn't predict, or it doesn't give a value which we want it actually. Now there comes after that there comes the machine learning. So when machine learning comes, it gives the computer that kind of ability without kind of explicit programming. I mean, like all the algorithms being designed, and all these algorithms which comes under this machine learning, they're developed based on data set. It is based on the requirement of a human being, or it is based on the requirement. It is based on the data set that we have with us. This machine learning algorithms were developed. I'll come to that, and I'll tell you how it is. Then the subset of that was the deep learning. We get deeper into from the machine learning to deep learning. What was the need of the deep learning also we'll discuss. So let us first talk about the first machine learning algorithm. So whatever I'm talking right now, before I start Gen AI, it is all about, I'm talking about the narrow intelligence only, artificial narrow intelligence. And once we start with the generative AI, the topic, from there we are trying our best to come to that general intelligence. Okay. So machine learning, all of you know, most of you who are in the academics, they know this. We have supervised, unsupervised, semi-supervised, and reinforcement learning. So what are they, and why this is being, how this algorithms were categorized, the machine learning algorithms were categorized, that is most important. Just learn this algorithm is not important. Why these algorithms were developed was important. So for example, if I take supervised learning, all of us know that there is a label data, and the data label data value could be of two types. One is categorical value, or it could be continuous value. When I say categorical value, it's a discrete value. So it can be binary, it can be multiple. And based on that, we can have multiple number of algorithms under that. And we call it a classification kind of algorithms. We write a classification algorithms to define or to identify the output in the form of classes, right? So where the values are say 1, 2, 3, or first, second, third, red, blue, green, or true, false, all those things. So the label value is something which is supervised, which is known to us, the target value is known to us. But then the another kind of value that we had under the supervised learning is the continuous target values. Continuous means the decimal values we have or the integer value we have. Say temperature tomorrow at 10 o'clock it is say 30 degrees. So yesterday it was say 30.5 like that. So the temperature values are known to us. So tomorrow, what will be the temperature next day on the next day? This is what we are trying to find out. So all the label, the target value, the historical value is known to us. So a data set with a label, with a continuous value and with a discrete value, they are categorized under the supervised learning. So we developed certain number of algorithms under the regression and a certain number of algorithms under the classification to do the learnings. Next comes the unsupervised learning. So what was the need of unsupervised learning? Obviously, we don't have a target value. We don't have a label in our hand. So so since we don't know the label with us, so we don't know the previous temperature, we don't know we basically don't know what we are given with some data and we are not able to classify, we are unable to classify into some targeted value. So those kind of data set, those kind of data set comes under the unsupervised learning. Now see the beauty, we are using a clustering algorithm for. So what is a, because since we don't have the label data, what we do is similar items we are grouping together, we make certain number of clusters. So since we know we are able to create some patterns. Now these patterns are in different clusters. And we are clustering the similar items only. Now there is one more need. The next need is complete, and it is all from the data set only. A data set which is not labeled, we applied the clustering algorithms to find the clusters. Next, we jump to the association rules, association kind of algorithm, which is again under the unsupervised learning. So what was the need of this association learning? Just because of one simple reason that we don't simply want similar items to group together. We want different items also to be grouped. The best example is if you go to a market, actually, the best algorithm was market basket analysis, priori or FP growth. So when you go to a market, if you buy a bread, obviously something related to that you will buy because you won't eat raw bread. So you will try to find out something related to it. So you are in your basket, now you are not going to have similar items in the basket. You are going to have different items. But these different items are connected to each other. So there are data set wherein you have items which you want to be together, which are different. So there we apply the association. So again, you might have understood that it is completely the supervised learning regression or classification algorithm was developed just because of the reason the data set was like that. Unsupervised learning was algorithms were developed just because of the reason that we want similar things together and also we want dissimilar things together because it is our need, the basic need, our need. Then comes the next one, which is known as supervised and semi-supervised. That means half of the things is supervised and half of the things is unsupervised. So I can take it in two ways. One is like I was able to create some cluster using clustering algorithms. Okay. Now similar items are together. So now what I'm going to do is I'm going to now these clusters which I got, which has got some certain number of values. These clusters C1, C2, C3, say for example up to C10, 10 clusters I have. Now I will convert that cluster into classes. So there comes a new point. So there is a bag. There are so many number of balls into it, 10 different colors. Now I'm picking and I've already made a cluster and I put all the values also. Now the next thing is I got a new ball. I am picking a new ball from the bag. Now I am going to which cluster it will go. Now the cluster is we have already got the cluster. Now I can label it as the target. Now, one thing is very clear that with the unsupervised learning, we are able to create the labels. Now I can do simple classification for the new values. So I don't need to look for similar patterns because now we have the classes as a label. So in that scenario, we make use of the semi-supervised learning. Then comes the next algorithm, which is known as reinforcement learning. And all these algorithms are basically used for Gen AI, and it all works at the base, at the back. Now, the understanding of this is very important before we move forward. Next comes, so under semi-supervised, you have classification, clustering, both are required. Then moves to the reinforcement learning. This is a different kind of algorithm, which is and which basically does the classification at the same time it have a real world control. One best example is you are moving in a in a vehicle and there comes a one way route and you are on the opposite side. And when you are on opposite side, you are trying to travel. And if you travel, if you make a wrong choice of moving on from the other side. On the other side, you may find some people, the police, to put a penalty. So when you do a mistake, you will get a penalty, and if you're not doing a mistake, you will get a reward. So all the tasks that we are giving to a machine learning algorithm is a machine, and it gets an output, and if it is, and the output is, and the output is, just a minute, just a minute, just. Sorry for the interrupt. So we are into reinforcement learning. So reinforcement learning. So when you do something good, you'll get a reward, and when you do a mistake, you will get a penalty. So think about in terms of a system. You are giving a task to a system, and the system is taking a wrong decision at first moment. When it does it first time, that record that footprint will be recorded in the knowledge base. So that record will be taken as the reference reference output for the next same situation. So when a same situation arrives, and obviously it won't take up the same decision to get an output, which leads to a penalty. Okay, so reinforcement learning is you're reinforcing uh, you are reinforcing the system to do or take the correct decision. That is what is all about reinforcement. So all the examples, as you can see, the different examples are given at the bottom. Okay, talking about this machine learning, now these are the different categories of machine learning algorithm. Now, what is so good in that? I mean, is it machine learning can solve all sort of problems, all big, huge task problems? No, it won't actually, because the reason is it is a uh, handcrafted algorithm. All the algorithms that you find under machine learning algorithms, you talk about your clustering algorithms, your K-means, support vector machine, ensemble method, all Q learning method, whatever method, decision tree, whatever method based theorems, all these methods, it basically use a data set which are and the model is developed in such a way that you have a handcrafted feature with you. So you know what are the features that you have to look for to get an output, whether it could be a classification problem or it's a regression problem or it's a clustering problem. You basically know the output. You know that what I have to achieve in common. Okay, and to achieve that that goal, you know the features that I have to look for. That is what is all about machine learning. But this scenario is being completely changed with the introduction of deep learning. Now, machine learning has jumped; it has got subfield, and enter into a concept which is known as deep learning. Now, here starts our generative AI concept. So, when we talk about deep learning, all of us know that this is an imitation of your human brain. So, and as we have said, 10 raised to power 11 million neurons actually, which communicate with each other like anything for any. So you can understand that every human being, they have the capacity to think, react, take decision, response. All those things could happen even with unconscious mind also. All these things are happening so fast that we are in the stage of artificial general intelligence. Okay, we are not super intelligence. All of them are not super intelligence. We are artificial general intelligence. We are in that level. So we want that machine to come up to that level. Now, for that, the deep learning has started supporting us. So it mimics the entire neural network technology concept where you have inputs, where you have hidden layers, and when you are where you have the output layers. And all of you know the basic concept that we have multiple number of neurons, we have multiple number of these hidden layers, and this is basically because of the need of the data. No, our data are not limited. So the amount of data that you collect, that you are receiving through the IoT devices or all the devices around you, they are very huge. And it is kind of time series data, or it is of different types of data and second to second data, milliseconds to second of data. And this is huge. It is getting stored at every places. No, we need to analyze this. To analyze this, definitely we need a structure which takes up and which does a kind of in the hidden layer, it does all sort of calculation which we cannot see with our naked eyes, but it does all those things, can figure out or find out all the features, unlike machine learning. Because machine learning, I already said, we are looking for a features that is known to us. But here in deep learning, we are not looking for the features we know, but it automatically, since it is all connected, each and every neurons are connected to each other, all the inputs and the subsequent hidden layers, they are associated with weights. They are propagating and they are moving in such a way that they uh, they abstract each and every small minute features from the input that we are giving in order to get the most accurate outputs. So there comes the deep learning concept. So this is a big picture, as you can see from the picture. I'll just make it a little bit. Now you can see this is artificial intelligence. Under that is machine learning with a lot of programs, but they're all handcrafted features. There comes a neural network concept, and from the neural network concept, it becomes quite easy for us. Like a human being, when we do a task and we make a mistake, we'll come back, we'll correct it. In a similar way, we try to make the system similar to us. Okay, so we applied this deep learning models, and most of you basically know there are many different types of deep learning algorithms, starting from your autoencoders, your RNN, recurrent neural network, CNN models, LSTM models, reinforcement models. These are all models which comes in transformer. These are all models which comes under deep learning algorithms. But these are the algorithms which together onto a platform, different platform of generative AI creates or makes the generative AI a successful uh, a successful technology. So the success of the generative AI is just because of these deep learning algorithms, the combinations of the deep learning algorithms. Okay, so today we'll see what are the different types of generative AI algorithms. Before that, as you can see in the middle, actually, when we talk about generative AI, it has got different frameworks. They are the algorithms, or we can call it a framework. I'll just say one by one, just because it is inside that. So I'll just tell you what are they. So, for example, the first one is the RLHM. It stands for the reinforcement learning with human feedback. So, human is giving a feedback. Based on that, reinforcement takes the decision based on which you either get penalty or reward. So, it is completely guided by the human being. So, we call it reinforcement learning with human feedback. The next one is hallucination, which is a model that basically generates incorrect or fabricated information, and that is not supported by input data. That is one way. And the next one is Flora, which is a method, and it's a fine-tuning large language model, and is efficient, low-rank adaptation for better performance. That way it is being used. Then comes, you can see a few shot. Few shot learning is nothing but a machine learning approach, where the models run from very few examples. It won't require greater amount of data, but a small data set. Then comes the transfer line. You might have heard of this concept. Like if you have a similar situation, and if you already have pre-trained data, I can apply the pre-trained data into those similar situations to get an output. And very familiar, all of you might hearing every day, every time, this large language model. So what is this large language model? So it's nothing but it's a neural network trained on a it's a neural network only, which is trained on a vast amount of data. It could be any data. It could be text or image or video, audio. It could be any, and it generate and it understand and generate human-like language. So that is the large language model. It's a combination. It's a group of different deep learning algorithms only, which you make use to get output for the generative AI. Okay. Now we move on to the generative AI. So coming to the generative AI, as I said, from the statistics, we jump to machine learning algorithms where we have only few features, handcrafted features. We know the feature based on that only we are looking for output. Then we have features which is getting abstracted or which is getting out from the deep learning by the deep learning itself without our intervention. That was something so beautiful. And from there, there only we started thinking about something next. So if somebody asks you, is deep learning or machine learning or statistics, are they intelligent? Yeah, they are all intelligent algorithms only. But if you ask me, I'll call it traditional methods. Now they become traditional method. Now when we say generative AI, it is the next level edge. Okay, so so far we were looking at data set. We are trying to create some output out of it. Now the era is different. Now we want to generate something. We want to generate a content like a human does. Okay, so we want to ensure that we should reach to that general intelligence. Now, for that, there are few. We have started with text. We started with text. We move to the images. Then we move to your videos, audios, and then we have photo videos. So these are the four basic thing we are looking for, which has to be generated automatically. Okay, and getting generated means it doesn't mean that you are copying something. It is not copying something. I'm taking a picture of mine, and the same picture of mine is getting copied. Is not the concept here. It's a concept that you have raw pixel with you. I have my photo. I have a raw pixel, and these raw pixels will arrange itself in such a way that it will create my image. So that's an idea. So we are trying to reach to that level of intelligence. Say, for example, an artist, when look at a particular person, by looking at one gesture itself, he may be able to make the figure or make the sketch of the particular person. Okay. In a similar way, what the system also, we want to generate a system which randomly arrange the pixels in such a way that it creates an image, or it create a movie or a video or something like that. Okay. So let us. So my topic will be completely around this text. It will be around your images. It will be around the audio, and it will be around the video. This is what we are looking for. Before that, let us see what are the different algorithms that we have. We have studied, as I mentioned, there are deep learning algorithms. These are the algorithm which is supporting the generative AI to give this output. Okay. Now to learn this generative AI, as you can see, it is being for quadrant, in which you can see in the first quadrant on the right side, blue part actually, you see artificial intelligence, machine learning, we have transformers, and we have prompt engineering. We will come to that. We'll discuss transformer also. I've already explained what is AI. ML is also explained. Prompt engineering, yes, all of you know. If you are able to write, if you are able to put a query in the appropriate, right, not appropriate, said in the perfect manner, the output also will be perfect. If you are writing your query, the question in way, you won't be able to get an answer in right. So then is making a model of your own. If you want to make a model, we make use of RAG. We'll talk about those technology also. Gen application, there's so many applications. All of you do understand. I'll show you some other figures also based on which you can understand the kind of applications you have. Then the API models, APIs. Okay, for Gen AI, there are various APIs. We have Hugging Face, we have Vertex AI, which is a Google product, and then OpenAI, all of you know, right? And their API best practices. So we make it sure these APIs to develop our Gen AI applications. So, okay. So what is this generative AI? So moving on, moving forward, we are developing an algorithm in which we have two parts. The first part is a generative model, a generative part, and the second one is a discriminative part. So one is generating, and the other one is criticizing. That is the idea. Criticizing means it is verifying and it is validating. Okay, so that is the idea. Say, for example, we are not just looking for a concept wherein the discriminative technique classify the input that we give. That suppose if I generate an image of a dog, and in the data set or in the data this knowledge base I have with the picture of this dog, I'm using a discriminative part technique to discriminate the dog image that I've generated, and based on that I'm classifying. Okay, so if it is correct, I will say if you find it is dog, it is cat. No, it does simple classification. So this is a basic algorithm that we have in deep learning. Right? So we call it a GAN also. We come to that also in detail. And the next one is like generative. Generative. I mean, generative means what? It is not about like dog. I mean, dog image will be. We are just checking whether it is dog and classifying it, but rather we have so many some pictures of this dog with us. Okay, and we are making use of this dog pictures, which is in the data set of the knowledge base, and then we are creating our own picture. Okay, so this picture is completely different from the input that I've given, but this is also a dog. So we have the system or the algorithm have seen so many different number of pictures, and based on that, it is sketching the image of a dog only. Okay, so this is what we are looking for. We are looking to generate this. So in short, if you want to summarize it, how it will be, when we talk about the normal machine learning models or prediction model, it basically works on a label, and based on the data and label, we try to classify. But when we talk about a generative model, we have unstructured the content. We don't know the content. Okay, so I want to create an image. I have some random pictures with us, multiple pictures. I have. Say I have a picture, 50 pictures, photographs, in which in 20, 25 images, I have some dog pictures or a cat pictures. So the generative model will identify, and if I want to generate a cat or a dog picture. So generative AI model will find out the dog or the cat from that images, and then based on that, it will create a image of a dog. So that's an idea. Okay, so all the input are the inputs which are raw, unstructured. Okay, so which one you call as Gen AI when we look for an output? So normally the function is like y is equal to say fx plus the bias, the function. So you have an input, and corresponding to that for a model, you get a value of input. So if it is a number or a discrete, we are looking for a number, say continuous values, or if you are looking for a classes like discrete, or you want to specify a particular class binary or multi-class, or if it is a Bayes theorem, so we are making it a Bayes theorem, so you are depending upon a probability distribution. So it is all not known. It doesn't come under Gen AI. Okay, but rather when we talk about natural language processing, that means we are translating, we are scripting, we are trying to we are trying to analyze a particular language, and okay, and we are generating a language. All this comes under what Gen AI. Or we are creating a picture, we are editing a picture, and we are changing the picture. It's the same way, like we are synthesizing the audios, and then we make changes on the audio part. So all this basically comes under Gen AI. So as mentioned earlier, there are the first one is text. We are going to generate a text. Second is image. Third is audio, and the fourth one is what? A video. Okay. So in normal case, like we make use of a training code, label data are there, build a model, and then you get an output. But when we talk about generative language model, it's different actually. It is quite easy for the generative language models to identify kind of whether to classify something, because it sees vast amount of data and it learns from it, and it can easily identify faster compared to what the data sets based on the data set, the given data set, and all. So I say that Gen AI is a type of AI that creates a new content. Okay, and that is based on what it has learned from existing content, and existing content is very vast. It's raw, it is everywhere. But how intelligently it takes the data, the information from there is the key point. Suppose if you do a search in our Google search, we want to search something, you will get so many vast number of pages in milliseconds of time. But how relevant they are, that is important. So the so you find that most of the things are not relevant also, and the information also mismatches. The information also are incorrect because people may put different, because it is open. So people may put a different sort of information which definitely may not be correct also. Okay, so there was a need of making a pure optimization in terms of taking acquire the correct information from the sources, right? So we have two models. One is the language model, is a image model. So for example, say if I say the input is text, if the input is text, the output that I'm looking for the text. So text to text. So I can translate, I can summarize. If you have a big paragraph in the story, I can simply summarize, do a summarization, and I can do a question and answer. I can do grammar corrections. All those things could be done from text for the text to text. And then the image, the output. So say for example, text to image. Text to image, obviously I can improve. What I can do is I can improve the image resolution, or I can I got a half knowledge about the particular thing, that can be converted automatically. It is generative. Then we have outputs, a text to speech. Well, that's well known. Everybody knows that any text can be converted into speech, vice versa. And then decision making outputs, a video, playing a game. Text, you're writing a text to create a video. That is also quite possible. Then image. Next is the input is image to text. What you can do with that? You are given with the image. I can look at what is happening. What is this picture all about? Like I can write. Then visualize question answer. I can do image caption. I can do super. Then if the image to image, I want to convert from image. So you have an image with a very less quality, low resolution that you can increase. You have a very old images with you, so you want to you want to recover that image, that also you can do. And then obviously with the set of images you can basically make animations also. That is why you want to recover. So now we move on to define the set of algorithms. Before moving that, how it works basically, Gen AI works based on the transformer. You have a transformer. So what it does is you have an encoding part and a decoding part. So when an input is given, you have a lot of data within. These data are okay, and it is compressed. It is compressed into a particular form. The dimensional reduction of that input is being reduced. Or that is one way. That is a normal way it's being done by the auto encoder. But in transformer, what it does is it is an attention mechanism. So it does the attention mechanism. We'll talk about that in the coming slide with the algorithm. So and then what it does is it generates a pre-trained transformer model. So what is this chat GPT? GPT, generative pre-trained transformer. That is what it is. So we have pre-trained model, transformer model, which only which is basically bothered about only the part of the module which is queried by a person. Okay, so if I'm querying something, only it will take the information which is important from a model and give it to us. Okay. So at the same time, hallucination is something which is bad actually. If we suppose, as I was talking about, well, actually, if we have wrong information in the depth, and if that also is being considered for an output for a query, for a prompt, then that is not a successful generative AI, right? So how it does? We have a prompt. It summarizes text of X, and it generates poem in style of X, a list of keywords based on semantic similarity of X, and all this prompting They, all this prompting will lead to a large language model. And the output will be simply what? And large language model I say is nothing but it's a deep learning algorithm. So it's a mix of these deep learning algorithm which use transformer, which in turn make use of this attention model. So it summarizes, it writes, and it gives you whatever key abstraction you want to do. You can. So prompt, they use a database from the database and generate the content. Okay. No, if you have all this things, say if you have text, image, speech, or a structured data, which is video or something, or you want to make a 3D model also. So in between, for doing this, definitely you should have a model. I said it's a pre-trained transformer model. So we call it in general, in technical terms, we call it foundation model. So when we talk about text to be converted into image, there should be a foundation model there. So we should have particular algorithm for that, which helps to convert the text into an image. So a foundation model is first created for this basic thing. And so basic algorithm is written to create foundation model for text to image, text to video, text to voice. All those things we should have a foundation, which is a pre-trained transformer model. Okay, and based on that, you can do multiple tasks. You can see on the right side, question answering, sentiment analysis, information extraction, image caption, object recognition. All these things you can do from there. Okay. So this foundation model that you create is basically uh, having these. It includes chat, it includes the text, and it includes the code. So that is the foundation. And it is for the language. And when it is for the vision, as you can see, these are the various things. Okay. Now, this is the application. So it gives you a clear picture about the whole the AI application. After that, we start with the techniques. So as you can see, when we talk about the text on the left side, please look at the left side. You can see a column wherein content will be generated, marketing, sales, support, it's general, note, attitude, and so many other things. When you talk about a code, it's quite see, it's not about just generating a content in your chat or something or any platform. Wherein writing a letter or email, it's not just about that, but it also is like you can write a code. It's code. So it understands the English language, it understands multiple other languages, it understands the coding also. So you can generate a code, you can document a code. What do you mean by documentation of a code? Nothing but line by line understanding of each and every code. And then you can convert text to SQL. Your web app builders are also possible, right? Then when we talk about image, so we have tools to generate images. Uh, Consumer, social media, advertising, and design. All those things can be easily done with the generative AI. Then voice synthesis, which is very important actually. Video editing and generation, that is another important thing. And finally, 3D model scenes, that also good. There are other things like when we talk about biochemistry, physics, all different types of usage of all those things could be done through the generative AI application. Now, what it does actually, one of the examples when we talk about Gemini code generation, it helps you or any other code generation, like ChatGPT or any other platform, being anything. So it debugs. The first thing is it debugs, as you can see. Any code that you can write, you can usually debug it, and line by line explanation could happen. It will tell you from which resources it is being taken, that is also possible. And then it does the documentation also. At the end, it does the documentation also, replication also. All these things can be done with these generative AI models. Now, one of the examples for this, but it is cloud skill based Google platform. You have this Vertex AI Studio. Some of you can look forward, but there are billings also you might have to kind of process for this, and you can work on that also. At the end, I will show you the platform. So Vertex AI Studio, it gives you like library of pre-trained models. So many models which are already trained. It is very much there. Okay, like when we talk about say Python, right? Python has got a lot of libraries, and all those libraries keeps what all inbuilt functions in it, and all of them are written. The beauty is like all of all the libraries are written in C, C++. Okay, so the weightage is actually C, C++, based on which library is written. So what is Python is just a shell actually, and it gives a simple, straightforward, simple command line commands actually through which we can access those. So we don't need to write all so many lines of codes to actually include all the header files of the libraries. Yes, we need to include libraries, but we don't need to define all these unique keywords to uh, tell the headers and all those things to do something. Now, what I say is the studio actually. Like we have Art Studio, we have so many others. Like Anaconda, we have so many frameworks are there under the Anaconda. Like it's a studio which is for AI. The tools are there to fine tune the models also. If you have pre-trained models, you can fine tune these models, and you can deploy these models so for the production. Then you want to make an AI, generative AI applications, you can make use of it. Then you have a community forum for developers to share ideas and collaborate. That is also possible. So Studio has got these many features, and what you can generate out of it. So you can have your own. So you don't need to learn basically lines of code, I mean the program, but rather with this visual Vertex AI Studio, you can create your own chatbot, digital assistant uh, output, and then custom search engines you can make. You can have your own knowledge base wherein you can keep the record of all the important things, and then look for these. And you can also generate training applications and many more things you can do with this Vertex AI Studio. I'll just show you at the end. And then there are so many tools, and I personally feel that I'll at the end I'll show you all the tools. Perhaps I'll be sharing this slides with all of you, so you can go through it. You can check all the tools as well. So these are the major tools that is being used by most of us. Actually, most of us use this ChatGPT. Gemini is also there. Earlier it was known as Bard, now it is and then we have ChatGPT 4, which is a paid version. GitHub Copilot is there. Scribe is there, Dual AI is SICI is there, and then Cloud is there, DALI is there. Okay, OpenAI has made this ChatGPT, and the higher version of that is DALI. DALI, all of definitely those who have into this particular thing, they know that ChatGPT is basically for text to text generation, and DALI is the next level, so you have text to image, and and above that is Sora. Sora is again OpenAI next level tool, which is basically is for image to image or video to video. It is like you have a movie of 3 hours, you want to make it short. You will find out the frames which are important that narrates the entire story, and it will make it very short for 15 minutes. So Sora those again by OpenAI only. It is under it is not yet in the market, but it is there. So that can be used to do that. Okay, so Gemini, yeah. So this is the Vertex AI, which has got a model garden. We call it model garden, wherein you have multiple number of views. Pre-trained models are already there. So you can make use of it to develop the system. Okay, so under model garden, you have this tensor flow model garden, Hugging Face model garden, and then you have PyTorch garden, Onyx model. So what are they? If you go in deep, go in detail, you have to get into it and register it, and do that you can get to know about it. So when I say TensorFlow model, it's a collection of machine learning models only, and it is implemented in your TensorFlow, and it includes models of natural language processing, computer vision, or we say reinforcement, or with the architecture like a BERT, ResNet. You have heard about ResNet or EfficientNet. Okay, so ResNet and LXNet, we are the versions of different versions of CMA model. Okay. It also provides your say tutorials, data sheets, pre-training, checkpoints, so many things it does. Then Hugging Face is the next one, which is a model hub and function as a model garden. It also focuses on NLP only, but it includes the computer vision and audio models. Okay, that's an addition. It also contains thousands of pre-trained transformer models like the ChatGPT, I mean GPT, P5, BERT, and that can easily fine tune and deploy across a range of tasks that you are looking for. Okay. And then PyTorch offers a variety of, again, a pre-trained model across the computer vision. That is again for an NLP. And the best example you might have heard of if you have done any experiment with your CNN model. So version of that is a YOLO for object detection. And you have ResNet, which I already said, for image classification, and several transformer models for this NLP. It is very much able to be. And next one is ONX model. ONX model, it is open neural network exchange. Okay, that is ONX. And it provides a collection of models which is compatible with this particular format only. And the interoperability between the different frameworks. Say, for example, your PyTorch, which I already mentioned, or TensorFlow or Keras, it is quite good. And it includes same thing only. It does the computer vision applications, NLP models, and optimized for deployment across the various hardware platforms. Okay, so this is basically the pro version is a free. It has got unlimited, not limited access only, but with $20 per month, you can access multiple things for that. Okay, this is what I was talking about, perplexity. So what is this perplexity? Okay, another tool. All of you use ChatGPT. I just want to show you that. Let me show. Doesn't this stop? Maybe it's done. Yeah. Hi everyone. I hope all of you are able to see this. This is like your
Yes,
chat.
sir.
Yeah, like the chat GPT. This is known as perplexity. I request all of you to just go once, at least once through this particular tool. This is really good because it will definitely help you to do a lot of those who are into research. Okay, so those who are in research, definitely they can look forward to it. Why I'm saying this, I'll just show you. See, in ChatGPT, a higher version like paid, not everyone is using it. But over here, this is free for, as I said, free with limited things. But for with Pro, even $20 if you are paying per month, that you may be paying for ChatGPT Pro. But it gives you a lot of research kind of. So, for example, I want to do any search on the web, I can focus on web. If I want to relate to academics, I can do academics. Maths, definitely I can do maths. Writing part, if I want to do, I can do it. Video, you want to discover some video, watch some video, you can do it. So, for example, academics, I'm putting academics and I'm saying that different AI, different algorithms in Gen AI. Let us see what it is. But you can see there are different algorithms it has shown. Okay, no, not only that, you can see that it is giving various other sources also. The source also. Okay, so each and every source you can go and you can check. Okay, from where it has come, and you can see on the right side you can see all the resources. So it is easy for you to even search a particular paper in this. You know that only is there to do all those things, but this is one way to be domain specific. You can do all this search. Okay, so you want to do some research on this DNA itself, you can search for that. You can search for videos here. Okay, you can see all these videos are here very much. You want to search for images, you can search for images. You want to generate image, that also you can generate. Okay, for that you have to pay also. Free may be there for 1 or 2 or 3 hours. Okay. Now, this gives you a clear, cut, simple, straightforward answers, and this is very accurate. What I understood is when I'm using Perplexity compared to the other one, it is giving me. And if you go for the Pro also, I'm telling you, each and every lines could be where from where it is cited. That also it will show you, even though it is giving you the results. Okay, so you can definitely make use of it. uh, and just try because it is good for the teachers, right? So this you can maybe. Yeah, go to the slide. Okay. Hmm. Okay, so now we move on to the algorithms. What are the different algorithms that are used under generative AI? As you can see that most of you find that it is generative AI. I mean, we are deep learning models only. Yeah, deep learning models only, but they're being used in a different way. And how that is being, because the whole concept is from there only. As we are go into the depth of deep of all the minute data, the huge data, we could actually find out something really. And what is important that only you have to find out from the raw data. Okay, so that way. So let us talk about all this. There are 10. We'll talk about all 10, and definitely it will cross. Uh, be with me because it will definitely cross maybe 3 o'clock. I'll try to finish before that. Okay, so the first one is generative AI. A knowledge of sufficient knowledge. I'll say at
Excuse
least.
me, sir.
Yeah,
Yes, sir, the presentation is not visible, sir.
it's not visible.
Yes, sir.
Oh, sorry. Okay. Oh, sorry. I shared the same thing. Yeah, is it visible now?
Fine, sir.
Yeah.
Fine, sir.
Sorry for it. Okay, so these are the 10 generative AI algorithms. So we discuss about all these 10 algorithms. So we'll see what is the difference between them, how it is useful in creating your text, image, your audio, video, speech, and all this. Yeah, so the first one is generative adversarial network, where then variational autoencoders, transfer models, diffusion models, recursive neural network, and then auto-aggressive, flow-based models, retrieval augmentation generation, conditional generative models, and the final one is reinforcement learning. Okay, we'll talk about all those things, and then finally I'll show you some of the tools that you can use for doing all sort of conversions, right? Now, the first one is all about generative adversarial network. This is not one single, this is a base model. You have multiple models which is being invented, and they are called as the popular variants of this particular model. Okay. So one basic model is here, generative adversarial network. All of the, the best example I would like to give is say two people are, I mean, two sets of people. They are playing the game, which is known as what? A tug of war. In tug of war, all of you know that we have to apply force to pull the other opponent people to our side. In tug of war, we are applying a force, the other people are also applying a force. So we are, if I say I'm applying a positive force, the other person is applying a negative force. Okay. So the positive force that I am applying is to win. The negative force that they are applying on us is to decrease our force. I mean, to increase for their win. So it is not like both are applying a positive force. It is like one is positive force, the other one is trying to decrease our force. It is positive and negative. That way we actually look for it. Okay. This method is also known as min-max algorithm, or if you have any time studied this artificial intelligence, you have came across with this concept of min-max algorithm. Or we and the concept is like, uh, for example, if two people are playing chess. When two people are playing chess, we really don't know who will win the match. Okay, suppose it starts at 10 o'clock. As time passes, uh, the number of pieces also reducing either side. Okay, so there are 16 pieces on either side. So when the number of pieces are decreasing, as time passes, it is easy for us to tell who will win the match when we are a human being. But for a system to understand this, what it does is for every move, it need to find out the best move. Okay, so I am from, at a black side, and if I'm trying to make a move from the black side, suppose number of pieces on my side is 10, the other side is also say 10. Total is actually 16, 16, but it's 10 now. Now I'm making a move. What will be my best move? so that opponent will get trapped or he will, some of his pieces will get trapped. So when I make a move that is being calculated. Okay, so we call it min-max algorithm, wherein max we make a tree, the max is at the top, the root node, we try to, for that one single move, a whole tree is generated in the system. Okay, so the algorithm is something like this. If you know, do deeply is one of the algorithm, one of the software which is the famous one. All of you, I know that. So what it does, it creates the whole tree for that one single our opponent. So if I make a move, I am a human being. So I can take it. If I am making a move, I will definitely, I am certain about only few movements on the right side or left side. The other opponent also will do similar thing. But here, the opponent, the system, I am playing with the system. The system will generate the whole tree when I make one move. Or when the system make one move forward, it makes the whole tree till the end, to the end. That means what will be the final result. At the leaf node, you'll find win, draw, or lose. But we as a human being sitting, even though we call ourselves intelligence, we may not be able to reach to that particular leaf node, like win, draw, or lose. So that is one thing. Okay. Now, in this case, in this model that is generative adversarial, have two things, as I was discussing earlier also. You have a discriminator and you have a generator. Suppose I got a real image of a image. Okay, there is another fake image is in the market. So, I'm generating a fake image with set of random pixels. And then this is being given to the discriminator. Okay, the discriminator has got a knowledge base wherein the real picture of the real image is there. So it gets compared with this, the fake one, knows that it is fake. Every time generator will try to generate an image which will look real. This is so dangerous. You try to understand. There will be a point when generator is able to make a picture or make an image which is exactly as real, like real. So it will become difficult for discriminator to discriminate that. So it will simply verify that validate it, even though that is true. Okay, so this is a person who could be danger for us. Okay, but we need this for so many applications, for crime applications, so many things. We basically need this. Okay, so so this is a basic fundamental thing for generative adversarial network, and this is a generative model, generative AI model. Okay, so the popular variants are like this. The first one is vanilla, which is the base method. And it consists of a simple generator discriminator method with no architecture model. Same thing. So this is actually is a vanilla. This is a small, thing, the basic model. Okay. Then comes the deep convolutional GAN, that is generative adversarial. Okay. So it uses conventional layers without pooling. In conventional layer, we know that there are set of layers, conventional layers, and then we have pooling layers also. Okay, and then at the end uh, we have the fully connected network. Now, in this doesn't have this pooling in both generator as well as discriminator. So it makes highly effective for the image. For the image synthesis, it make it very. So we are not decoding it. We are not reducing the dimensions. It will be as it is. Okay. So it is, and it also and what technique it use is like it uses a batch normalization and stride. Other things are same, like as we do for the convolution. The only thing is it does it without pooling, because pooling meant some of the information you will do some. Okay. Then comes the conditional GAN. So conditional GAN, the word itself states that both the generator and discriminator, they will be having some additional information, and these information is nothing but your class labels or other data. And the and the and the and for control generation, specific type of images or the output based on the input conditions will be given. That is basically the conditional GAN. Okay. And it is basically used for text to image synthesis or image to image, same thing. And another one important model is, okay, so if those who are doing right present some research, I request all of you to go through each one of these models also and try to see what are the shortcomings or research gap. So cycle GAN is basically is designed for unpaired images. Okay, unpaired images means images which are completely basically different. Okay, so for example, I have a photo. I want to convert that into painting. So I'll be using what cycle GAN. Okay, so that's an unpaired image to image translation. Okay, so converting one image which is in one form, which we call photo, into another form which is actually painting. Okay, next one is okay. So I hope so. This is interesting actually. Then comes pix to pix. So it is just reverse of it. So it's not unpaired actually. It's a paired image to image translation. Just opposite of this cycle. Okay. So here it requires what paired images for training and such as say sketches and the corresponding photos. So you have sketch and you have a corresponding photo. And the application is simple converting the sketch into realistic image. Okay. Which could be a grayscale image or you can actually create a color image also. Right. Then comes your super resolution GAN. So the word itself states that I have a GAN. And this particular GAN, what it does is generate high resolution images from a low resolution inputs. So how that is done, we will see in other methods also. And it introduce the perceptual loss, and that is to improve the quality and realism of the generated high resolution. Okay. And what one more thing is like it's like image upscaling the image and the video. Commonly used for image and video upscaling applications. Okay. Next is progressive code. So it increases, its job is the same. It does the resolution of generated image during training. So this gradual approach, it stabilizes the training and it enables the generation of high resolution images. Okay. And when you see the application, it requires very high quality images, such as when you talk about face, face images. Okay. The next comes the style GAN and then style GAN 2. There are two types, two different variants, I think. So it is to it improves the architecture and basically the training to produce even the quality which we are talking about, even higher quality than that. Okay, so it creates a photorealistic image of, say, for example, of your face, and it also gives a detailed control over whatever the image that you are generating. Then comes big GAN. It's a high. We call it big GAN. The word itself states that it is a high capacity GAN. So it scales up both the model and the data set to generate a very high quality images with large batch sizes. Okay. And especially what is it from complex data set? One example is like ImageNet. ImageNet is basically a complex data set. So from there, it can definitely create a very good output. Then comes InfoGAN. Okay. InfoGAN is the extended of your GAN and it maximizes based on mutual information that is between the subset of the generator input and output. So it allows learner to do not readable and distangle. It distangles the representation and it provides control over all features that are generated. Okay. And basic application is interpretability features abstraction. And then it comes to the last next one is VGAN, WGAN, GP. And for any new loss function, a kind of law, wherever there is a loss function, distance to address instability, and there is a model mode collapse issue that is being rectified by this. Okay, and it does it by doing a training and adding gradient penalty to it. So whenever there happens a loss, it gives a penalty, or otherwise. The last one is spatial gap. Okay. A spatial is a variant. It's again it's a variant and it generates a texture by capture all the spatial patterns, and it is applied to generate what I call say the image of material, some material or natural texture. So for example, a grass, or say you want to create cloud. So those things will be done. Okay, so these are the variants of the generative adversarial method, which is being used in the material. And now we move to the next one, which is a variation of autoencoder. Very interesting. It is all of you might have heard about autoencoder. So you are giving an input image. We want the same image in the output. Okay, so we basically want the same image in the output. So image, once again, you are giving an input image and you want the same image in the output. So what is the beauty? So there is a question that what we are doing. I'll tell you what we are doing. We are giving an image. It may have noise, but it get encoded, it get compressed, it got uh, we extract all the features. Since dimension is reduced because it is compressed. When it comes out uh, after the decoder, all the noise will be removed. Okay. So when I say simple autoencoder, it just encodes the input, compress it. We call it, we reduce the dimension. Compressing it, we are reducing the dimension, extract the features which is required and which is deterministic. And deterministic, when I say deterministic, we want only the features. If I'm talking about a cat image, so we know the cat eye should be of this particular height, size, length, color, and all those things. Mouth, everything. The features are well defined and deterministic, and you get an output. But there is another one, but we are interested in uncertain things, right? Because when I'm giving a dog image or a cat image, I should be able to create an image which is of a dog, which will be definitely different from the dog that I have given as an input. So therefore comes the variational encoders. Okay, so it has got a space. We call it latent space. So when it does the encoding, okay, so when it does the encoding, in the compression part, it has got latent space. And this latent space is nothing but it has got the probabilistic uh, distribution. Okay, and a probabilistic distribution will leads to take out the samples which are most important as per the requirement of a user. I mean, you want to generate a dog of a different color and other things. It's not the same as what we have given. For that, we make this. Okay, so that is actually a variation or the interest. You see the use cases. It is image generation, anomaly detection, and a feature lab. Right. Then comes the transformer model. So these are the two models. I hope all of you understood what is a generative model. Then we have a variation encoders. Next one is the transformer models. So what we are using right now, generative pre-trained transformer. Okay, and then we have a BERT, which is bidirectional encoder representation for transformer. Then we have T5, stands for text to text transfer. Okay, in this transform model, I'll just come with this figure actually. This is taken from the data science video. And this figure, how it looks like is we transformer means we have attention mechanism. Okay, so if you give all of you can see, if you give an input, there is a output also. When you are giving an input, actually, we have multiple head attentions. You can see there are multiple head attentions. There is feed forward, and ultimately we want an output, and that output is completely based on the probabilities. Okay, so when I'm using a softmax, it means what? I'm doing a classification here. And so when I give an input, actually, there is multiple head attention. It means when I say head attention, means I have a resource which consists of a book. From that book, I want to get a particular chapter, an abstract of a particular chapter. And that book has, suppose, say, 100 chapters. Okay, so I need to do a search, and I don't want the summary of the chapter, but a small portion of the chapter summary, a small portion of a particular chapter, 50th chapter somewhere. So in order to reach to that particular point, obviously all other chapters need to be included. Okay, so this attention mechanism. So we say attention layers. All these attention layers will try to look for the keywords that I have given and try to match it with the one which is more accurate, which is very close, and try to reach to that particular point and try to take it up. So this is a concept actually. So it's scaled down. It does all linear search, and with this multi-head attention. And this is the way the transformer works. Pre-trained the transformer works for here. ChatGPT also, right? Okay. Next is very interesting model, which is known as a diffusion model. And this comes with your value 2, which is the next open source for by the OpenAI. OpenAI has created one more which is above it, that is Sora, which is not right now in the market. DALI and stable diffusion. So DALI 2, what it does. So we are giving a text and it is generating an image. Now see the interesting part. What diffusion does. I'll come with a example with this picture. Okay, taken from internet resources only. All of you can see there is a glass here on the top. Okay. So here. Okay, in this glass, I'm dropping a liquid. Or I'll say paint. Okay, so as soon as it is dropped, you can see it is getting dispersed. It is completely dispersed. Dispersion is happening. So I'm going to record what we drop as soon as it drops, and when it is getting dispersed, all the information. See, each and every drop, it is getting scattered, and the cohesion is getting decreased, density is getting decreased, and it is happening point by point. Okay. Now the thing is, if I can record this information, can I record an information back? Reverse. Can I do a reverse diffusion? So this is diffusion. Diffusion is keeping the knowledge of point by point movement of these paint from this top point to say for up to this particular point. So for a paint dot to reach to this particular bottom part, there are all other point, drops also just about from here to here. This information is recorded. Can I reverse it? So this is diffusion to reach to the maximum information. Can I diffuse, do a reverse from here? I want to come back to this point. That means I want to come back to this point. So reverse. So camera has got all these tricks, all of you do understand. So what do you do is in diffusion model, we make use of a algorithm which is known as Markov chain method. Now see what is Markov chain method? In Markov chain method, it is like the immediate point. So this was my drop, first drop, and certainly it is moving down. So I got another point, and this bottom point is the last point. Say for example. So there is no cross dependency. So this point is not dependent on this directly. Okay. So after this, next point is this. So Markov chain states that the current, the next step will be is totally dependent on the current step on it. It is not dependent on the previous step. Okay. So that is Markov chain. So look here. All of you please listen carefully. This is a picture of a dog. Now I'm moving forward. So what I'm trying to do is I'm trying to add noise to it. Okay, I got a very clear picture. I'm trying to add bit of noise to it. I'm doing that, adding it till it gets completely blurred. So now I just have the pixels values. Now I want to get it back. So this pixel value, the entire pixel value. Now I am doing reverse diffusion. So I'm trying to create the dog out of this pixel value. So just think about it. So you have just pixel values, pixels only here. Now, since you learned how by adding a noise, you reach to this particular one frame, and this is one standard. Okay, so how can I get back from this to this? So what I do is reverse diffusion. Okay, now that is done by your CNN model only. All neural network model, deep learning model does this. So it takes the random all these pixels, it's try to combine and try to come back to its original position. Okay, so one of the method is known as what CNN UNet. UNet is used. So using that you can come to it. Now the point is now. So this is a normal thing, right? So from a dog picture, I got a pixel, and from pixel I got it back the same dog. Think about it. Getting a dog, it looks different. So can I add noise in between in such a way that this dog will become a cat? Can I add noise in such a way that this dog will take a different shape? Or it becomes the image of a different breed? Is that possible? So that is a question. Okay, so this is actually a reverse diffusion. You can see in this diagram, it's a forward diffusion and the reverse diffusion. So in generative AI, what we do is we make use of a CNN models wherein we add denoise it in such a way that we won't create the same. It is easy to get this same picture, but we try to get a different picture. That is what I've shown in the earlier slide, if you remember. Okay, now what we are trying to do here while adding this when I say adding noise, what do you mean by adding noise? So if you see this 3D model here, what I'm doing is in an image, I'm trying to add noises inside, and I'm finally I get a full noise. So I want to come from here to here. It is not necessary that I'll come step by step back to the same path. I can directly come from here to here also, quite possible, because I have these information. So uh, pre-information is already there. So rather than coming to here, I can come directly here. So I can come from here to here directly. So it's very fast process. But so the idea is here it is the noises is being getting added in a in a method which is known as probability distribution. So we do a probability distribution, and we make use of a simple method which is known as Gaussian distribution. We call it Gaussian. You can see this is a Gaussian curve, actually, normal curve, also known as a normal curve. See, we always understand that this is the peak of a real image, and this is the peak of what completely noise thing. Okay, so the transition from each level can over here, as you can see, the transition from each layer from here to here or here to here is quite possible, because we know Gaussian is always like this in natural curve. Okay, so this is actually known as what diffusion model. Next. Next comes known to everybody, recurrent neural network. We make use of this is for the text generation. When you type something in your mobile or any of the platform right now, the next word get automatically. You can see the next word. You click on tab and it will be printed, right? So what it does it is how it is doing it. Okay, it is definitely it has learned. When I say pre-trained transform model, it has learned all those things which is already there in the resource, and just make use of it. And whenever comes the same kind of wordings or same kind of sentences, it gives you an idea, right? So the first model, the deep learning model, which was introduced, for this is a recurrent neural network. Recurrent neural network also has got a lot of variations. So if I say I am making a sandwich with a peanut and butter, uh, sorry, peanut butter, and uh, what will be the answer? The answer will be 1 So it predicts automatically. So you have an information which is very less. All of you can see this information is very less. What if suppose I have, say, 1 page of information, and the last sentence I have to predict something in the last sentence, there is a fill in the blanks like this, and we are not making use of the sandwich and all those things. Like this particular information you could collect on the first line of the page. Okay, so I'll state it again. There are 100 lines in a page. The last line and the last word I want to predict, and the information about this is in the second line of the page. Okay. Uh, what does it mean? If I make use of this recurrent neural network, it will not help me, just because of the reason that it doesn't have that memory to keep it. So, okay, so it just keep the information of just previous or previous to previous in lines only, and based on that, whatever it comes in next, it just print it. Okay, now do it in a different way. Say this is all in a Gemini. We are doing it in Gemini only. So if I ask a question, I am making a sandwich with peanut and butter, and you put a filling of it. So you can see it gives you a lot of information about it. So it's not just about jelly jam, it can be a variety of it. So it is, these resources are very much, they are pre-trained, so it is there. Furthermore, so suppose somebody is asking what is the meaning of life, also you get a lot of information about this. All these things are very much there as a pre. So I was talking about RNN. RNN has got multiple, this is basically used for time series actually. It is basically used for this kind of NLP also. Wherein one-to-one information is. For example, I'll just give you, if you take an ECG, it could be either normal or abnormal. Yes, output will be normal or so. You give an input ECG value, which is a continuous state of time given durated continuous value ECG, and the corresponding value will be what, a normal or a abnormal. So this is one-to-one kind of RNN, recurrent neural network. The second one is in this case you can see I am giving an input and which is an image actually. Okay, and I have text. As you can see, how many number of words? 1, 2, 3, 4, 5, 6. I have one too many words. Okay, so an image, which is one single unit, and you have multiple words to describe the image. So that is one to many. Then we have model, RNN model, which is many to one. which is say, for example, I love this movie. So I love this movie. As you can see, number of words, multiple number of words. The output will be only one. It states it gives me an answer like it is positive or negative. So it will be positive. Then we have many to many. As you can see, many to many, a week of temperature. So next week of temperature, this week of temperature, and then next week temperature. Okay, this week, next week. Next is many to many. So these two are just a variant wherein a time series, past thing, and this is a future thing. This is current information, the same moment I want the output. So English to French, you write English statement and then convert that statement into other statement. So this is a recurrent neural network, which is definitely part of your generative AI. Okay, that is only helping you to find out the next step. Okay, now recurrent neural network has got problem because isolation is a short memory. It doesn't have memory. At back, if you go back, there are number of lines. It won't keep in memory because it doesn't have memory. So then we move to next one, which is known as long short-term memory. In long short-term memory, you have enough number of gates. There are main gates, three gates, input, output, and your forget gate. So whatever information is required, it is kept. As I was mentioning the second line. So this particular LSTM will have the all the previous record in the memory. Whatever is not required, that only will be removed from the history, and then otherwise it make use of it. So, but the problem with this LSTM was that it has more number of gates. The computation cost is high. So there comes the variation of that gated recurrent unit, which is the GRE. So here the number of gates are less. Here we have reset and update. So what is required, that only will be kept, and what has to be projected, that only will be projected. So with that, it put a limitation. So RNN basically encounter with the vanishing gradient problem. When I say vanishing gradient problem, it is something like you got an output and which is not correct, and you are coming back. You are doing a back propagation. While doing a back propagation, if you have 10 layers, you are able to reach to only the third layer, up to the third layer. Okay, you could not reach to second and one. As soon as you reached up to three, it vanished. Vanished means you are able to correct your information. That means it is not reaching to first and second layer to take the input from there. So weight adjustment is over by the third layer itself, and then you do feed forward. We won't say the output that you got is correct. Okay, so that is a vanishing gradient problem. Now there are different other variants. I will not discuss about it. You can all of you can go through it. So these are the different. It's not just the three algorithm which is RNN, LSTM, and GRE, which supports your NLP and all those things. These are other algorithm which is on the right, which I could explain, but I think the limitation of time. It is. Or I'll just tell very fast. So when I say bidirectional, you can see both the ways. RNN is basically we are moving forward, but in when I say with RNN bidirectional, we are forward as well as backward. Okay, both the ways it could do. Second one is attention mechanism. Already all of you understand what is it. Only the relevant part will be taken care, and that only will be taken for the calculation of attention score for each input that is in relation to other, and making it effective in task, which requires a long range of dependence. Right. Then next is attention-based RN. So we are just adding the attention to RN. That's all, nothing else. Then deep definitely means it is something which is tagged in RNN. So it is not one layer of RNN. We have multiple layer of RNN. So it increases what we model depth and capacity. So each layer that we are designing, it processes what I input, which is sequential, and it passes the output to the next layer, and it allows the model to learn in some hierarchical fashions. Okay. Then echo state network. When you talk about echo state network, it's a type of recurrent neural network with a large. It's a fixed and as well as a sparse connected layers, and what I say, it's only trainable output ways, and it makes training efficient also. Okay. And it one more thing is like the layer transforms the input into high dimensional space, and it captures all the dynamic patterns. Whatever dynamic patterns are there, it simply captures. And if you ask me, it is mainly used for your time series forecasting. For example, you want to know the traffic condition next week on Saturday. That will be known to you, or you want to do a pattern recognition of a traffic of a particular junction. That is possible. Okay, so that is actually cyclostate. Okay. Next one is variational RNN. So it is what you are doing is we combine the RNN with autoencoder. That's all. What is autoencoder is known to everybody. So we just add RNN. So it is basically used for speech synthesis, and it does the video generation also. Okay. And the next one is a neural Turing machine. A neural Turing machine, it's it is enhanced with some external memory, which allows you to read and write. Okay, it is like mimicking. You know what is Turing machine? Right? It's like mimicking a Turing machine, and uh, because of that, this capability it enables us to learn all the algorithms, and will help you to remember all the dependencies, long-term dependency, and solve all the tasks that requires memory, such as say we call it say sorting or copying something, and they're very useful for this complex reasoning and tasks require like memory manipulations. Okay. Now next is neural style transfer. So talking about neural, I'll explain with the picture, but at the same time, I'll just tell you the use cases to image art generation. It's a photo enhancement, and it is a creative application in design and digital art. So the tools that are used for neural style transfer is DeepArt, DeepBreeze generator, fast style transfer model, artistic style transfer in Google Color. Uh, so most of the kids at your home also might be using a lot of applications in the internet. They are changing their face, make funny faces, so many things they do, right? So this neural style transfer, yes, I can convert that image into a different form. So that is quite possible, right? So all these tools which are available right now, they do apply this neuro style transfer method to create convert one image into a different form. Okay. Auto regressive is same as what I talked about. That is a text generation. It is GPT only. That's all. Auto regressive. The word itself states tells you that to generate a sequential data. Okay, and make use of this previous data. So this is same. As you can see, this is auto regressive. This is not an auto regressive. So this is not connected. This here you can see it's all connected. So previous data is required for the next one. Then flow-based model. Uh, it is an invertible transformation. That is between the data and a simple distribution. I'll come with. Say for example, the popular model we use is a real value non-volume resolving image generation, data compression, and generation of other forms of high dimensional data if possible. So what it does is it learns the bi-objective method. That means it reverse or inverse. I'll show you an example. So say for example, X, there's a flow, it does the inverse transformation actually to get it. So here the flow is getting converted in a different form, and inverse of that will take back to the same form. Then is the conditional generative models. So in a normal scenario, when I say conditional normal GAN, there we are not putting any conditions. Okay, but when we say a conditional GAN, that means you are looking for a specific output. All of you can see two different diagrams. When I say conditional, it's just an X which uh, is being discriminated by the discriminator for all the fake images that it comes for real. Apart from this real, I'm putting a Y real, which is an additional thing that I'm adding to it, additional thing, which could be like telling a little more feature about it, or maybe another set of what do you say, the notes. For example, 10 rupee note earlier, they were different fonts. So I'm giving two 10 rupee note. So I have a condition that it is not 10 rupee note has taken different forms in real, in past. So two different real one and there is one which I'm generating. That has to be that need to be get discriminated. I hope this is clear. So this is one is where you put some conditions when you have multiple options. Now this is also very interesting and important one. Retrieval augmented generation. I'll just explain with the example. I mean the figure. It is again taken from the internet source. You can see retrieval means all of us know that when we talk about chat GPT, it's a LLM model. So this LLM model uh, has already pre-trained a transformer. All the data source where we train, make use of it to create the content for us. Now, in this particular case, when we say retrieval augmented generation, first what we do is when comes a query, that query will first go to a database. Okay, it won't go to this LLM model, pre-trained model, but rather it goes to a specific knowledge base. And this particular specific knowledge base is the knowledge base where uh, the query that has been posed, the relevant information is there. No, we are not finalizing the relevant, but it goes to the resources, which is what I'm asking. Okay, so for example, I want to know what is computer graphics, and the best library maybe in India is some IITs, and in that IIT, a particular library, in particular department, it might have. They may have virtual. It is a virtual library, and I could easily read. So first, it goes there, look up all the knowledges, I mean all the books or whatever informations, and then try to. And after that, once you receive it, we make use of a retriever. We call it dense retriever. Or there are other options or also other method also. Traditional TF, IDF, BM25. These are known as a retriever. So the retriever will collect those information, bring it back, and then it get added with your question. Okay, so you have a question, it looks up in a knowledge base, specific knowledge base. From there, some information document is collected. Now your question and your document together will go to your LLM model, your chat GPT or any Gemini or whatever. And after that, this LLM model will go, and because this is a pre-trained data transformer, right? So it goes, it takes those information, check with this specific knowledge which is collected, see, validate it. If it is all same, it is uh, good, then it will give an output. So why we are doing this? By doing this, what you are getting is, even though we have pre-trained data, if you remember initial point of time when you are typing something, it always shows as in an output that if you try to get an information after September 2021, you won't get it. We have information up to ChatGPT and like that actually. So to avoid these kind of scenarios, also to avoid the scenarios wherein some of the private resources were not reached, those resources access, suppose you have directly, because ChatGPT and other things won't go to a private firm. It would never get enter into a private database and collect those informations, right? So if you have a private information, you're taking that also, and then you combine you with your question, you're giving to LLM, and LLM is making use of this and compare it, and then give it to you. That is amazing. Now you're going to get a result which is much more accurate, right? So this is actually known as retrieval augmented. Okay, so here it is augmented and generation. It is also what do we call it for RAG. The last one, this is the last one, and in 5 minutes I'll finish it up. Reinforcement learning. So the last is all of I have already mentioned. It's a ML program, so one of the ML program. So if the algorithm does the correct thing, it gets reward. If it doesn't do it, it will get penalty. Okay, so this is what it happens. So the basic step which is involved, it's first it has got a state, and then it does the action, and it does the reward, and then policy, and finally whatever it learns, it is kept. Okay, and so you have some multiple popular different types of reinforcement learning. See, every day some researchers, some groups of collaborative projects which is done on a particular domain, or a particular application, they come up with a new algorithm. And those are the algorithms that you see, what I'm showing you, the popular models. You may be able to create your own model also. And these models actually does something better to fill the gaps that you have in the existing. So that becomes basically a research, right? So over here, the RL, which is a reinforcement line, what it does is like for one simple example, say for example, if it is for the text generation. Okay, so multiple texts that you have uh, that you are training initially actually those things uh, which are about to pre-train, which you are about to set it as a pre-trained data that need to be verified, that need to be correct. Okay, then only that can be called as a pre-trained transport value. So that is important, right? And for that, while doing that particular process, so whenever it encounters a situation where the decision goes wrong, so it comes under the category of penalty. Okay, so similar kind of position comes, we cannot take it, and then what it does is it, 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 those things will not be taken care and will not be stored as a pre-trained data. So those things will be removed. Okay, so this is all about the reinforcement learning for generative AI. Okay, now with this, this part is over. And this is just a use case again taken from the internet resource. You can see multiple applications. Most of us, I mean, those who are professors, most of them are doing research in this area. I'll okay, I'll share my details also then. So there are healthcare people are working, which is basically they are working with medicine, drugs, so many things are there, treatments. And when we talk about finance, we are talking about algorithms to develop for the tradings, uh, market analysis, and then we also talk about frequency, high frequency trading algorithms. Then content creation, which is much more popular. This could be for the art, it could be for the movie, it could be for making a serial, or just think about a scenario I'm asking you everyone. We are into an era, maybe in 10 years or 10, 20 years of time. There won't be any theater actually, because movie theater, PBR, maybe sometimes. Like, you are creating, there won't be a need of directors or actors or anybody else. You yourself can be an actor in your film. You can create your own heroines. You can create your villain by yourself. The whole story you can narrate. You can make the entire picture 3 hours to 2.5 hours. You can put whatever you want in that movie. All those things are possible, right? And the entire thing is basic, is completely possible to this generate. Okay, so that's one example actually. The last is like natural language, text generation, sentiment analysis, and language translation. So all these things, these are some of the use cases and the applications. Okay, now I just talk about the tools, say within 2 or 3 minutes, and then this I will wind up. Some of the education tools, since I have already shared this PPT, so you can also go through it. These are the tools which you can use for your education. Okay, make it easy. You want to do a presentation, just give the content, you give the word like I want to have a deep learning for presentation. So it will give you a kind of chapter by chapter that can be converted into. Okay, but this slides that I have prepared is not from this. Those things. I did a research, I went through different content, and based on that, I created it. Okay. Now, let us talk about this some of the sources, open source, a text generation. So all of you are familiar with this GPT. What is the T5, which I had mentioned earlier also, and there CTRL, which is by Salesforce, and you see all these are open source text generation tool. Okay, and the higher phase, higher version definitely will be uh, not free, so that you have to pay. So this is a text generation tool. The next one is again a text generation tool, but higher versions. But that is professional version. We have to pay. So each one of this, I won't ask you to actually go through each one of them, but there are some of the important ones. Say for example, Jasper AI, you can try. Write Sonic, you can try. Copysmith is one of the good one actually. And Right Sonic Pro. Right Sonic has a lot of features that you can try. Gemini and Binge, yeah, this is free, but the higher versions, yeah. So this is a text generation. Next, text to image generation. So if you want to generate text to image, so this is all you can see is I think open source. Yeah, all are open sources. Uh, all these open sources I have gone through uh, multiple open sources. Many are up to after a certain point it is like professional. You have to pay, but basic features you can definitely uh, you can make use of it. So DALI is there, but that is mini. Mid journey you might have heard of. Every time you would have heard of whenever you see the video. Runway ML also you have heard of. So please you can use this also, text to image. Then comes text to video. These are all text to video. There are open source. So what we have, text to image and text to video. So Runway ML is there for text to image also. So multiple things can be done. So all this can be done, and there's a paid version on the right side. So this synthesis here is one of the important one. You can go through it. Victoria is also one of the best one. Deep Brain AI is another best one. You can go for it. Just have a look, just try it, and you can make use of it to make your content and for education purpose as well. Next, open source for text to audio and audio to text reverse. This is known to everyone. This is very much available, and most of them you are familiar also. This conversion is everyone is using day to day life also. Then image to video. Okay, you are given with images, and we are grouping these images and converting it to. So DALI is one which is very famous that you can use it by OpenAI. Professional also is there. You can see these are all professional higher versions that we can make use of, image to video. Then video to video. What do you mean by video to video? What is the need of this video to? Say for example, I have a 3 hours of movie. I want to make a trailer out of it. So we have to do editing, cutting, and all those things. Instead of doing that, I just make use of this video to video AI generation tool. Give that movie. I give also. I can put a condition also. See, these are all research areas. Say, for example, I want to make it conditionalized. So in such a way that the story of the movie in the form of video should be made as a trailer in such a way that it won't give you a complete picture of the movie, because otherwise nobody will go and see the movie. So it should be done in such a way that uh, it should be done in such a way that it gives a very abstract information and gives some of the scenes through which you will be able to go. I mean, it makes you to go and see the picture. Okay. So this is what basically is video to video. And many more other applications. This is one application myself. Okay, so in order to create any presentation slide, these are some of the famous one. Presentation AI, Tom.api. This is so many. There are so many others also. Canva also, best way you can take it in Canva. This Pro version is also there. So presentations, to make a presentation slide actually in specific subject-wise topics for educational purposes is quite easy nowadays. Otherwise, you have to spend hours and hours. So that is quite possible. Okay, with that, I'll end. I think I took more time because this is a technical presentation. Definitely will take time. I'm not going when because even I have prepared so many codes and other things. I'm not going to that level. But I hope that I am able to give a complete picture of what exactly is Gen AI and where we are now and what is expected next. Okay, so what is expected next? It's simple, like those who really want to do some research, definitely can collaborate. Because my area is this, actually my area is intelligent transportation system, but this is one of the area where I'm also looking forward because I am heading the vertical, this is vertical of image processing as well, which is a new responsibility. So I am myself is too interested in that, even though my interest is basically with AI with intelligent transportation system, which was my PhD, but now something that came in my mind is electric vehicle. Okay, so those battery management system and other things. So I want to connect the intelligent transportation system with this vehicle technology. Okay, so the energy management. all this. So that is what I'm doing in services. But some or other way, definitely in intelligent transportation system, we talk about extemporating the responses that you need for taking an action. For all those things, I am doing that also. Right now, I'm showing kind of interest has generated for this area too much. So I'm looking forward and something. Get connect to me. Connect to me. I'll type my email ID, which is Dr. Viju Jobs free at the rate email.com. You can connect to me actually. It will be nice basically because see, research only happens when multiple people are doing work together. Not a person in the same institution, but the people from different areas, in different places, because that's a collaboration. One more thing, like when the research opportunities, I'm working with the Christ, so I think PhD options is open now. Those who want to take up a PhD in price anywhere, it's not, but it is just open. So I said actually, so anybody who want to do connect to that also that way also can people can do. Okay, so yeah, thank you so much. I'm so happy that most of you have shown patience to listen to this, though it becomes very fast. I definitely want to hear your feedback, and if you have any queries, you can definitely ask me.